Assalamualaikum warahmatullahi wabarakatuh. Today, we would like to present to you about RC phase shift oscillator to generate 56 kilohertz. Okay, this is our group. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ilani Najwa binti Hamid and my metric number is CE 1824.
My name is Cao Jun and my metric number is CE10025.
Hello and hi everyone. My name is Indri Baran. My metric number is CA180019. In this project, I will present our part, which is introduction, objective, and conclusions. So the first one is introduction. Our project is we do the RC phase oscillator. So oscillator is a circuit which produces a continuous repeater alternating waveform with any inputs. Frequency oscillator are 55 kilohertz. So in this project, our group is using the 55 kilohertz frequency. It's different with other groups. So and the third is the process to design the circuit RC phase shift oscillator by using the electronic software, which in this project we're using the multi-sim software to final simulation, and the early simulation we're using the Tinkercad. So we move to objective. So in this, our project objective is to design the circuit and generate sinusoid waveform of RC phase shift oscillator. And the second is to verify the functionality of RC phase shift oscillator. And the third is to analyze the simulation software and manual calculation of RC phase shift oscillator.
So in my part, I will present about the design procedure of RC phase shift oscillator. So here is the design procedure to design the RC phase shift oscillator. The following steps are required. So first of all, we need to assume the value of oscillation frequency F0. So we can choose any oscillation frequency according to our design. And the second one is choose the value of capital C. So the C will be equals or less than 1 microfarad, so we can choose the value of capacitor C using this. So that will be always less than or equals to 1 microfarad. So calculate, the third one is calculate the value of R using 1F0 equals to 1 over 2 RC square 6. So the fourth one is calculate the value of R1 using R1 more greater than R. So to prevent the loading of the amplifier because of RC network, it is necessary that R1 greater or equals to 10R. So we can calculate the value of R1 using this. So the last one, calculate the value of RF using RF equals to 29R1. So increase of RC phase shift oscillator, the RF will be always equals to 29R1. So here to obtain the amplitude, we can be obtained by connecting back-to-back signal diode in the circuit. So these are the design steps, and using the step, we can design the RC phase shift oscillator at any frequency. So here is the calculation part. So F0 is given according to our design step. So first step is choose the oscillation frequency. Because F0 is given here 56 kilohertz, so we can consider this oscillator frequency, that is 56 kilohertz. And the second one is calculate the value of capacitor C, and the C will be less than or equals to 1 microfarad. So here our group is choosing 0.1 microfarad. And the third one is calculate the value of resistance R. So here the oscillation frequency is equals to F0 equals to 1 over 2 pi RC square 6. So according to the formula, we can find the value of R. After calculate the value is 11.6 ohm. So the resistor R will equals to 11.6 ohm. And the next one is calculate the value of R1. So here the R1 is greater than and equals to 10R. This is the condition, so the R1 is equals to 10R. So put the value of resistor R, that is 11.6 ohm, and then calculate the R1. So here the R1 will be equals to 160 ohm. And the last one is calculate the value of RF. So in case of RC phase shift oscillator, Rx is always equals to 29 R1. So here, after calculating the Rf will be equals to 3364 ohms. So we can choose approximately value which is 3.3 kilo ohm. So insert the calculation value into the RC phase shift oscillator circuit. So based on the calculation, the value of R, Rf, R1, and C are placed on the circuit. The circuit also added the back-to-back Zener diode, and the Zener diode is added to stabilize voltage across its terminal within given limit of line or load change.
For the discussion, for each component that RC will provide us is the degree phase shift, while the total of 3RC will give it about 180 degree phase shifting in the circuit in the feedback loop. Okay, for the second point, as you can see, the circuit is not well balanced in the value to generate 56 kilohertz because from the simulation we have used ON 741. Okay, this ON is generally used for to generate frequency that is less than 1 kilohertz. However, we still can generate the circuit by manipulating the value in R1, RC, and VCC with VCE by by using the method and try and error. Okay. The third point is we put the value like 3.3 kilo ohm in RF and R1 as 10 ohm and C as 0.1 microfarad, which you can see in the simulation too, it gives a lot smoother waveform. As you can see, the reason why, because the ON itself is not compatible with the circuit, as it can generate uh, a low frequency that is less than 1 kilohertz. A lot smoother is more compatible to the lower frequency. So by changing the value of component, we can generate a lot smoother. Like the simulation one, we use the frequency OM 741 and we put the calculation, the value of calculation, but the output generate is quite shattered, like triangular waveform. It's like pointed one. So by manipulating the value, we can get a lot of smoother waveform. So um, last but not least, the last point will be this phase oscillator is quite simple and it is easy to be calculated and to generate in a lot of stable waveform. However, in order to generate a smoother waveform, it's rather time consuming. As you can see in the simulation, okay, in order to get the smoother waveform, we have to try and error, which is we have to change the value of R, C, and B, E, or VCC and VCC. And we also have to calibrate the time base here with the channel in order to find the amplitude of the waveform. Okay, that is it. Okay, thank you.
So we move to the conclusion. So how we can summary conclude in this our project is the first one is the successful to do the manual calculation and final simulation in multi-step software, and the second is through the lecture and group discussion we had able to investigate the frequency of RC phase shift oscillator by using the 55 kHz frequency oscillator, also to generate the waveform. As you can see, it's at figure 5 show it our waveform. And the third is this project grouping is also make us learn to analyze the RC phase shift oscillator circuit in multi-sim software. So in this case, we're using the multi-sim software to do the to generate the waveform, sinusoid waveform of RC phase shift oscillator. So for it, we also have to be able to learn and understand the flow of the process doing the oscillator in fully detail as presented in this report. So from our report is we doing the introduction about how we process the oscillator, process our RC phase shift oscillator. So from first until the end. So the last is the RC phase shift oscillator circuit and successfully designed, as we want to compare both result simulation software and manual calculation. So the basically is the manual calculation is to support our so whether the simulation software is correct or not correct. So we do the manual calculation to double it's correct of the frequency of RC phase shift oscillator. Okay,